Okay, welcome back everybody. Jumping back straight back into our Bahamian landscapes. Okay, the last lesson we did before Easter consisted of how the Bahamas started to form. Okay, as you can see, we're going to continue on with some of that here today. But we're looking at the Bahamas and the Caribbean in general and how it formed. All right. I would strongly suggest having a little glance back over some of the pages that you highlighted for that topic, or for that lesson, I should say. Alright, so you're up to date and fresh on that information. Okay, and today we're going to zoom in a little bit. We're looking at the Caribbean, how it formed, and now we're going to look mainly at the Bahamian banks and our main process which caused them to form in the way they did. Okay, so it's our sedimentation again. A lot of this stuff, even though some of it might sound kind of intimidating, a lot of it links directly back to our limestone topic. Okay, and I'll try and point that out as often as possible, so don't worry too much if there's a lot of information being thrown at you. A lot of it is very similar to our limestone. Alright, so I am currently on page 14 of Bahamian Landscapes. Alright, the Bahamian Landscapes textbook, page 14. We're going to be working through quite a bit of the textbook today, and then we'll look briefly at a PowerPoint also. Alright, so first thing is, although there are signs of erosion, alright, such as cliffs and sinkholes and blue holes and so on, the Bahamas is essentially a depositional landform or landscape. Okay, so it's made mainly of deposition, and again, it's deposition of those sediments. Alright, so we're going to look at how those sediments were deposited first in the ocean and then came to breach the surface. Again, in the previous lesson I taught you through a series of 5 diagrams which helped to kind of display this. Alright, so we're mainly depositional, so where the land has breached the surface of the ocean, so the island bits that we walk on, that is all deposited material, deposited sediments which have built up over time. Alright, so sediments can be and are produced in many ways: chemically, biologically and physically. Alright, so chemically, by evaporation leading to precipitation of salts and sediments in seawater. We'll look at that in just a few minutes. Biologically, from skeletal remains of marine mammals and plants. Alright, so by the breakdown decay of small sea or marine means ocean, so sea life, animals, plants and so on. Okay, biological, think of that, bio, living things. Okay, and then physically, by erosion from the coasts or coral reefs. Alright, so, or of the coast, so again, erosion caused by the ocean. Alright, I've put out here just how sedimentary rocks form, so I've included those 3 bullet points and the first little bit here. So if we go all the way back, if we think of the islands of the Bahamas as just huge big chunks of limestone rock that we walk around on, drive around on, they're formed in the same way. You have a tiny limestone rock or a huge island made of the same stone, they form in the same way. So first of all, sediments are produced through these things, these processes, and then ultimately these will be converted to solid rocks by cementation, okay, which we talked about in the last lesson, in a variety of ways, or a process known as lithification, rock making, where it layers up. Remember we talked about lithification before, so where all these sediments layer up to form that new rock. So you can put out here how sedimentary rocks form. Alright, that will help you, this bit will help you with an assignment later this week. Alright, so let's move on. Let me just move this down a little bit. Okay, so in the Bahamas there is no volcanic material and no igneous rock, nor are there any metamorphic rocks. Of the sedimentary rock types, only limestone are found. Alright, so that's the first thing. Alright, go back to our limestone. We have no volcanic material, no igneous, no metamorphic. It's nearly solely limestone rock. Alright, once we know that, then we should be able to understand how these other little bits and pieces are formed. We know the properties of limestone. It's permeable, it allows water through. Okay, it's easily eroded and worn away by that carbonic acid in the rain. Alright, we did all of this when we covered limestone. So now we're back to our limestone again. Very simple. Now let's go a little bit deeper though. Okay, we're mainly formed of an oolithic limestone, alright, which is the basis for much of the land and all of the higher land in the Bahamas. So we're going to look today as well at ridgelands, the highest areas of our land. Okay, So what we've said now is it's sedimentary, it's limestone, and it's oolitic. So let's have a little look at some oolites. Okay, so on to page 15, next page. Alright, so just to again exemplify or amplify, I should say, a borehole in New Providence. So a borehole is when you drill down and take a sample of the rock deep into the ground. Okay, the first 38 meters or 120 feet was found to be entirely oolitic limestone. Okay, so once they drilled in that far, all of the rock or geology they found was all the same type. Okay, so then what we look at is the production of this sediment. Okay, so it makes sense first of all to see what just produces this sediment. So where does it come from? So there's three major types we want to look at. Okay, the first one I'm talking about is skeletal. Now we talked about this on the previous page of biological breakdown. All right, so this is fairly easy to understand. It refers to the way skeletons are part of an animal or plant. Tiny shell, a sea urchin, a sea spine, or sea urchin spine, a piece of algae, something like that. Right. So what happens is these break down, they die or they break down, they fall to the bottom of the ocean and they start to layer up. Okay, and what happens is they break down into small little sediments as they stop living or as they break apart. Okay, now there's some more detail we can go into. All right, in our case study about the Bahamas, all right, the skeletal grains consist of, first of all, calcareous, okay, green algae, which is exceptionally important. Okay, so that's the first one, these green algae which are broken down and become sediments. And then also this stuff called foraminifera. Alright, so foraminifera, some of you may have heard of this before. It's a single-celled marine creature. Alright, and they make up over half the sediments found in the ocean floors. So there's countless numbers of these small little creatures. Alright, and actually, just interesting as well, it's the presence of the two coloured varieties of foraminifera that gives the attractive colour of the pink sands in Lutus. So they're also involved in making up things like the conch shell and whatnot else. Right? So first of all, you have sediments are produced through this skeletal process. Okay, so on to the next page, page 16. All right, we're only going to look at half of this here. So there's a second way. We have our skeletal sediments, okay, which come from living, broken down organisms. And we've also got this thing called cryptocrystalline grains. Okay, not cryptocurrency, cryptocrystalline grains. So again, the fact that they're called grains means that they're non-living. Okay, and we're looking at the crystal formation of these grains. So I'm going to skip on to calcium carbonate, which again we've heard about in our formation of limestone. It has a common crystal form called calcite. Alright, so again look at that, calcium calcite. So the crystal that's found in calcium carbonate is called calcite. But when it's found in the ocean, most calcium carbonate is produced in a slightly different crystal form called aragonite. Now again, the vast majority of our sand is aragonite sand. Alright, so what happens in the ocean is this calcium carbonate changes its crystal. Alright, so if you read the sentence above, it's about how how grains which apparently become converted from any original type into a new crystalline form. So in the ocean you've got all this calcium carbonate bounced around, which would commonly form a crystal called calcite, but in the ocean it is actually produced in a slightly more heavier form as well, alright, known as aragonite. And we call aragonite grains, we call them aragonite sand. Don't worry about this little bit here, okay? In the next video I'm going to move on and start explaining that in just a few moments.